All right, so we're going to continue working with inverse functions today. Hopefully today will be a little more to your liking, won't be as different as yesterday was. The definition of an inverse function. The functions f and g are inverse functions if, and this is important, f of g of x equals x for all the x in the domain of f, and g of f of x equals x for all the x in the domain of g. Now, this is real easy. You're going to like it. So what we do to show that f of x equals 2 and g of x equals x over 2 are inverse functions is we do f of g of x, and then we're going to do g of f of x. And if they both equal x, then we're good to go. So first off, f of g of x. Well, f is 2x and g of x is x over 2. So it's 2 times x over 2. And 2 times x over 2, 2 on top, 2 on bottom, is just x. So then we're going to do g of f of x. Well, that is g, which is x over 2, of f of x, which is 2x. So it's 2x So it's 2x over 2. Those 2's cancel, so that equals x. So we got an x, we got an x. So we can say that f of x and g of x are inverse functions. Told you it wasn't hard. All right, so let's show that f of x and g of x are inverse functions. So we need to do f of g of x, and we need to do g of f of x. So f of g of x, well, that's 6 over x plus 4, because that's g of x, minus 4. Well, that's 6 over x plus 4 minus 4, which is 6 over x, which you know is 6 over 1 times x over 6, 6 and 6, so it equals x. Now we're going to do g of f of x. So that is 6 over x minus 4. That's our f of x that's getting plugged into the x plus 4. So 6 over x minus 4 is 6 over 1 times x minus 4 over 6 plus 4. Well, 6 and 6. So now we have x minus 4 plus 4. Well, that just equals x. So f of x and g of x are inverse functions. Okay, so real quick at the bottom you have some notes. It says to find the inverse of f of x algebraically, use the steps below, and my steps didn't show up here, so you can read them in your notes. Oh, look, surprise, there they are. Fantastic. All right, so let's just move on to example 3. And it says determine whether f of x has an inverse function. If it does, find the inverse function and state any restrictions on its domain. Well, the quickest way to determine if it has an inverse is to graph it. But we can start to get a little more simple with our graphs because we know so much about parent functions now. We know that the domain of this function is going to be 4 to infinity. And that's because we can't have anything less than a 4 right here for x. So that means 4 to infinity, because we know the shape of this square root parent function. So now we do the horizontal line test. So we draw a horizontal line, only hits it in one point. So we say the inverse exists. Okay? If it does, find the inverse function and state any restrictions on its domain if necessary. So we're going to take our x's and y's and we're going to switch them. So we're going to write x equals square root of y minus 4. Well, to get rid of that square root, we need to square both sides. So we're going to get x squared equals y minus 4. Add 4, add 4. So x squared plus 4 equals y. Now, you know right away that this is a parabola. But our domain for our original function can't use every single value. So if you look back up to the steps, which yours are on the previous page, it says state any restrictions on the domain of the inverse of f, then show the domain of f is equal to the range of the inverse of f, and then find and the range of f is equal to the domain of f of -1. So go back over here. What's the range of our original function? It's 0 to infinity. Well, when we come over here, this equation right here, y equals x squared plus 4, you know, looks like this. You know that looks like that. And so when it says state any restrictions on the domain of f inverse f, which is this one, we know the domain needs to be 0 to infinity, and the range is 4 to infinity, because our domain and our range just switch places. So as much as we know this is a parabola, we only want the domain to go from 0 to infinity. So all of this is not really going to be part of our graph right now. And if you think about that idea of drawing the y equals x and folding it, it makes sense that that's kind of where it's going to land. So that's what we have over here with this red part. So what we say here is the inverse of f of x equals x squared plus 4 for x greater than or equal to 0. So we found the inverse and we're stating the restriction on its domain. All right, so let's try another one. Determine whether f of x has an inverse function. Okay, so we need to graph it. So you know what this looks like. Right? You know it does that. You just took a big quiz on it. You did very well. So we do our horizontal line test. Only hits at one spot. So our inverse exists. All right, let's see what's our domain. Well, you know the domain of the parent function x cubed is -infinity to infinity, and the range is also -infinity to infinity. So that's good news for our inverse function, right? So now let's find our inverse function. We're going to do x equals -3 plus y cubed. All right? We'll just switch the x's and the y's. Plus 3, plus 3. X plus 3 equals y cubed. Well, the only way to get rid of a y cubed is to cube root both sides, right? So we get the cube root of x plus 3 equals y. Well, you know this parent function also, so hopefully you know that this means left 3. So when we graph this thing, go to negative 3, and hopefully you remember what this looks like. It's the same as this one, except it's kind of flipped over, right? So what's the domain of this? Well, without even looking at the graph, we can just look at our original function and know that it's negative infinity to infinity, and our range is negative infinity to infinity also, and our graph just confirms that for us. So we say for our inverse function, f of negative 1 of x equals the cube root of x plus 3. And there are no restrictions on the domain because the domain is negative infinity to positive infinity. So there's a little word problem here. You should try to work this one out on your own. And when you come into class tomorrow, this is what we will go over.